Hi there, and welcome to your lab instructions. I plan to do this for each lab. This is a quick lab, so this is not going to be a long one. First of all, where do you find your lab assignments? Well, they're under the orientation module, under the course syllabus where it says all due dates are here, and you look for the lab assignment tab, and then you click on it, and here you will find all of your labs. The lab this week is measurement and the metric system, and you're going to answer all the questions, and it's due on August 31st. So here's the beginning of that assignment in terms of the problems that you have to answer. And the first question is to convert something from miles to kilometers. So what you need in this case is a conversion factor, some equivalency between miles and kilometers. And this is something I would always give you in a problem, or you would have a chart that has these listed. In this case, on page 3 in your lab, there's a list of conversion factors. So you would just look through this list and try to find something that equates miles and kilometers. And there's one right there. There's actually another one down here a little bit lower, but doesn't matter which one we use. We'll use the one I just highlighted. And so what do? Well, you've got your 10 miles and you want to turn it into kilometers. So you need to multiply it by one of these equivalencies, and then you're going to get an answer in kilometers. So that's the equation, and now I'm going to put in the numbers that I get from the conversion factors. 1 kilometer is equivalent to 0.62 miles. Now, why didn't I put the miles on the top and the kilometers on the bottom? Well, that's important, and you have to look at the units, because if I had done that, then my answer would have been miles times miles, which is miles squared, divided by kilometers. So my answer would have been miles squared divided by kilometers, which makes no sense. In this case, my miles are going to be divided by miles. They're going to cancel out, and my answer is going to be in kilometers. By looking at the units, you can figure out how to arrange this conversion equation. So in this case, I take 10, I divide it by 0.62, don't multiply it. This is in the denominator here, and you get 16. The next question is asking you to convert between centimeters and feet. And if you look down here, there's a conversion factor. The third one asks you to do a conversion within the metric system. If you watched video intro 1b.3, you saw me explain how to use this particular figure. And I realized you don't have this in your lab, but you have this picture now. You can come back and look at this whenever you want. And you can use this to move up and down the metric system as I explained in that video. The other part of your lab that you might not be familiar with is density. And density is how compact something is. Sometimes people confuse density with mass, and it's not the same. So look at these two boxes. They have the same volume, but one of them has more red balls in it than the other. So that one is more dense. It has more material packed in to a given volume. Look at these two situations. These are round balls, one's cotton and one's a BB or some sort of marble. And they might take up the same volume, they have the same size, but the mass of the marbles is much greater than the mass of a cotton ball. So again, that's going to be more dense. In this case, it's because there's more mass, not necessarily more objects, as it was in this picture here. Something more familiar in terms of density, which is used in lots of different situations, might be this image down here, the population density ranking in the states. So number 1 is the state that has the most dense population, and the 50 is the state that has the least dense population. And so in this case, the density is people per square mile. So for example, number 1, which looks like it's New Jersey, has the most people per land area. And then Alaska, which is number 50, has the least number of people per land area. So that's another way to look at density. How much stuff is squeezed into a given area or volume? The formula for density is important to know for our class because we're going to be using it for lots of different concepts. Density is figured out by dividing the mass by the volume. Now, if you have a rock sample, such as in this picture, we can determine the mass by putting it on a balance, like this, and we read off the mass in grams. The volume, we can do something kind of tricky for something like a rock, and we can submerge it in water, because it turns out that a milliliter of water is equivalent to a cubic centimeter which is also a volume. So for example, this particular rock displaced 200 milliliters of water, so its volume is 200 milliliters or 200 cubic centimeters. Another way to find volume, if you have something with right angles, is you can just do the old length times width times height volume calculation that you probably did in math class a long time ago. So take a look at this object here. You're given the length of the sides and the mass. Go ahead and pause the video and see if you can figure out the density of this cube. All right, so density is mass over volume. So the mass is 600 grams. And the volume is going to be length times width times height, which is 6 meters times 6 meters times 8 meters. Do that multiplication on the bottom and you get 288 meters cubed. And then you divide 600 by 288 and you get about 2.1 grams per cubic meter. And that's the density. Remember, when you're done with lab, you're going to scan and upload the pages right here where it says submit lab number 1. And if you have any questions about the lab, remember that you should come to my office hours, or we can do the live chat. Here are the office hours, live chats on Tuesdays from 1 to 2, and we can talk about the labs. Also, remember that there are discussions for each lab that you and your classmates can have to help each other out. I hope this helped.